turn to page 185. We're going to take out our highlighter a bit here. First thing we're going to highlight is a quadratic equation. A quadratic equation has a quadratic in it, which is a second degree term. Some sort of squared. And our job now is to figure out if we can solve all sorts of equations that involve squared. And actually, in the history of mathematics, there was a time where being able to solve things sort of gave you power. And there was actually little competitions going on. Friendly competition, someone would come by and say, I have a number in my head, if I add 3, it's 7, can you figure it out? And the other person would be like, yeah, that's easy. That's 4. But the challenges would get a little bit heated, and there'd be times like, if someone figured out new math, they wouldn't necessarily share how they solved things. They would just give the puzzle. They would give a puzzle like, wow, I have a number squared. I subtract 5 times that number, and I get 6. Can you tell me a number that works? Yes? 6 works. Is that the only number that works? Probably not. -1 also works. And it becomes a little bit more of a challenge. And if I gave you a lot bigger numbers, you would be like, oh, that doesn't look like much fun anymore. If I said that I have a number squared and, I don't know, I add 15 times that number, and you're like, oh, now the mental math is getting bigger. And it happens to equal -8. Oh my goodness, now we're dealing in negatives. Can you tell me what works? And it all of a sudden is like a little bit tricky to do your guessing and checking and figuring out. Oh, this, and sometimes, see in this one, sometimes, like I think in this one, I made one that actually has no numbers that work. But how would you know? So it comes to this, and I've showed you this before, that this is super hard to guess and check because you're adding and subtracting a lot. But if we make one side equal to 0 by subtracting 6 on both sides, adding and subtracting numbers to 0 takes guessing and checking. But if you can change it to multiplying, two things that are multiplied to equal 0 is called a very, very important property. The zero product property says that if two things multiply to get you 0, one of them has to be 0. There's no other way. There's no other two numbers that exist that if you multiply them together you get 0 unless one of them is 0. Pretty easy logic to understand, right? So when I factor this to be yellow, when I factor this to be x minus 6 and x plus 1, I now change my adding to multiplying. And if it's multiplying, we can use the zero product property to say, well, either this one is 0, so x is 6, check it out, 6 worked. Or this one is 0, x is minus 1. check it out. It works. In fact, on the other one, if I wanted to make it work, let's say, change that to 44, and now I have something that works. But guessing and checking would probably take a long time. But if I moved it over to equal 0, oh, I have to do one other little tiny switch. Make it -15. No, I still screw up. I gotta make sure I get this right. No, I have to make it, I can keep it to +15, but I have to make it -44. So when I move it over, it's +44. Can you see two things that multiply to give you a last term of 44, but add to 15? 11 and 4. And they both would have to be positive. So now, if this one's equal to 0, your answer for x would be a -11, right? If this one was equal to 0, what would your answer for x be? A -4. And if we double check, -4 squared is 16. -4 times 15 is -60. -60 plus 16 is -44. We have solved the riddle that someone could give you. And if you figured out this mathematical strategy, you now control the game. Because you would, like Romans would do this, where they change questions like that, and you'd be like, ha, here's a question for you. It took you a long time to solve it. You give me a question like that, and you get the answer right away, and they're like, how did you do that? And then they would usually just not tell. In fact, mathematics over like a long period of time, when someone found out something, they often didn't tell. Because holding the information gave you power over somebody else. Okay, so let's go to example 1, and now we can solve questions by using the zero product property. It only works if one side is equal to 0. So in A, it's like, ooh, I have one side equal to 0. Is it possible to change this to multiplying? Well, my first value is x squared. My last value is 56. In superfactoring, if you can factor it, it would be easy that this has to be x and x. That's the only way to get x squared. Your last one is 56, so you need to know your times table. Is there anything that multiplies to 56 so that your outside and inside, right, our outside and inside here have to make 1? 8 and 7. That subtracts 81, so let's try. So I put 8 and 7 as my first guess. I need a +1. So to get the +1, my 8 would have to be plus 8x. My outside would have to be minus 7x. Double check. Do I still get the minus 56? I do. So now the zero product property says if you change this to multiplication, one of those has to be 0. If it's this one that's 0, what could x be? A -8. If this is the one that's equal to 0, what could x be? What would make this 0? X would have to be 7. And we get 2 answers to this question way faster than if you tried to guess and check. But if we do check, 7 squared, 49. 49 plus 7, 56, minus 56, 0. Perfect. -8 squared, positive 64. Plus a -8, 56, minus 56, 0. Why doesn't it work if the other side is a number? Yeah, like 22 could have been 1 and 22. It could be 2 and 11. It could be 3 and 22/3. It could be 1.76 and another number to be named at a later time if I had a calculator. Right? There's an infinite amount of things you could break 22 up into. So it will not work if it's equal to a number. So if you get something like this, you have to multiply everything out, combine like terms, move everything over to get it equal to 0. So first, I'm going to multiply this side out. Do you see that your first one will be 3x squared? If you want to write out minus 18x and plus 1x, that's fine, but we will get very quick at doing the outside and the inside and putting them together all in one step. Are you okay with what I just did there in one step? I said my outside was going to be minus 18, my inside plus 1, minus 18 plus 1 will be minus 17, and then my last one, minus 6. This is equal to 22. So if I want one side equal to 0, I have to move this. And we've got a challenging one to factor here, but I think I really want you to start thinking of first and last and outside and inside. And when you look at your first and last, can you see that your first one only gives you one option? You know it has to be a 3x and then x. Now 28 has quite a few options. So you're going to have to do some mental math here. Okay? Give me any of the things that multiply to 28. Nice numbers. How about we start with, I know it's wrong, but I'm going to start with 1 and 28. If I do 1 and 28, I'm pretty certain I don't want to put the 28 here and the 3 here and the 1 there. My outside and inside won't make 17. It'll be way too big. If I put the 28 here and the 1 here, I'd have 28 and 3. Well, that would make 25 if I subtract it. Doesn't give me 17. So 28 and 1 I can throw out. What should I try next? 7 and 4. Now it's going to make a difference where you put the 7 and the 4. Right? Because if I put the 4 here, I'll do the wrong way first. If I put the 4 here and 7, I get 12 and 7. Does that make 17? No. But if I put the 7 here and the 4 here, I get 21 and 4. 21 minus 4 is 17. I need a negative 17. So I would need to have a negative 21 and a plus 4. One of the most powerful things you can do when factoring is pick an answer even if it's wrong and check and find out it's wrong. As soon as you plug numbers in and check the outside and the inside and you find out it's wrong, you'll be like, oh, I see what I could do to make this better. And usually you'll find the answer quite quickly. If you just look at it and don't try anything because you're afraid you're going to pick the wrong answer, it could take forever. So don't be afraid to try something that doesn't work with your factoring, because usually it will lead you to be like, oh, here I've got outside is 21, inside is 4. I need to make 17. That would work if I subtracted, and then figure out your sign afterwards. Then, I'll start with the easy one. If it's equal to 0, I'm pretty sure you can tell me what this one is easy. What would x have to be? 7. This one's a little bit harder. What would x have to be? To make that 0. And what you can do, you won't, I'm going to tell you, you're not going to write this down because you're going to get really good at these, but you can actually give yourself a tiny little equation to solve. Make it equal to 0. What would you do if you were solving this in grade 9? Would you move the 4 over and get 3x equals negative 4? And then if you wanted to get the x beside all by itself, do you see that you would take that -4 and divide it by 3? Could you do that green in your head? I think you could. So I don't think you'll write down that green part. I'll show it here. You might write it down today to sort of remind yourself, but you're saying, I want this 3x plus 4 to equal 0. Right? You didn't need to do it here, right? For sure, you could do this in your head. Could you move the 7 over in your head? I'm pretty sure you could.
Attention, Sturgeon Heights. For all the students that have signed up for the career in law enforcement, police, detective question and answer presentation, you can head to room 2B4 at this time.